Hello and welcome to lesson 13.3, measures of relative position. Today we're going to be talking about the z-score. We're going to be talking about how things are related and how many standard deviations away from the mean something is. So we'll go ahead and start off with looking at this picture. This picture represents the movie download times in minutes, has a mean or X bar of 14 and an S standard deviation of 4. So if we put our 12 minutes in the middle and then I add 4 minutes to 12, I get 16 and then 20. If I take 12 and subtract 4, I get 8 and then 4. And so as we are looking at how far away things are, we're going to be looking at how many standard deviations away. So I'm going to put this X right here because that would be 16. I'm going to put this X right here. If I take 4 away from 12, that would be 8. And then 4 away from 8 would be 4. So we're looking at where the values 6 and 20 are in respect to the mean. How many standard deviations away? So the number 20 is 2 standard deviations above the mean, and the number 6 is 1.5 standard deviations below the mean. As we're looking at how many standard deviations away something is, we are talking about the z-score. It is a way to standardize our measurements. So we're going to be looking at finding z-scores next. So our z-score formula, we have 2 versions, one for a population and one for a sample. We're going to 9 out of 10 times be talking about a sample, but you'll notice they're very similar. So to find the z-score, I take x minus the mean, and the mean would be mu in a population or x bar in a sample, and divide by the standard deviation, O hat in a population or S in a sample. Again, this is the one we're going to use the most, so I would jot that down right now. Z of x is equal to x minus x bar divided by S for standard deviation. All right, so let's try a problem using z-scores. So it says, Raul has taken 2 tests in his chemistry class. He scored 72 on the first test, for which the mean of all scores was 65, and the standard deviation was 8. He received a 60 on the second test, for which the mean of all scores was a 45, and the standard deviation was 12. In comparison to the other students, did Raul do better on the first test or the second? So we know score-wise, he scored a 72 on the first and a 60 on the second. So he did better score-wise on the first test. But we want to look at the z-scores for each. And so if you'll go ahead and on your paper, divide it into 2, we're going to find the z-score for the 72 and the z-score for the 60. And we're going to see how many standard deviations above the mean or below the mean each score was. All right, so this is equal to the x value, in this case, 72, minus the mean. Remember, that was 65, divided by the standard deviation, in this case, 8. So grab your calculator and type that in. 0.875 standard deviations above the mean. Z-scores can be whole numbers or decimals. For 60, then, we're going to do the same thing. 60 is the value. We're going to subtract the mean, which in this case is 45, and divide by the standard deviation, in this case 12. So we get 60 minus 45 divided by 12, or 1.25 standard deviations above the mean. So if we want to compare him against the other students, he did better on the second test. Better than the other students. And the reason is the average was only a 45, and he has a 60, which is 15 points above the mean. And his Z-score is much higher, and that means he did better than they did as a whole. So again, Z-scores are going to be used when comparing different things. We're going to go ahead and do another problem with Z-scores, and we're going to look at a light bulb. So think about light bulbs and how long they will last, and the fact that they have different lengths of time that they are reported to be able to make it. So on this problem, we're going to be using our Z-score formula. Again, X minus X bar divided by S. And our situation is a consumer group tests a sample of 100 light bulbs. It found that the mean light bulb expectancy was 842 hours. You're going to want that written down. And the standard deviation is 90 hours. One particular light bulb from the Dura-Bright company has a Z-score of 1.2, and we're going to find the lifespan of the bulb. So basically, we're using the same Z-score formula and working backwards. So it is Z of X equals X minus X bar over S. We're going to plug everything we know in and then solve. So the Z-score is 1.2. We do not know the X. We know the average or mean is 842. And we know the standard deviation to be 90. So I'm going to go ahead and put the 1.2 over 1 so that this looks like a proportion. And we're going to cross multiply. 1 times X minus 842 is just X minus 842. And then 90 times 1.2. 90 times 1.2 is 108. Again, grab your calculator if you don't have it. And then we're going to solve for X by adding 842 to both sides. So X represents 950 hours. So our bulb that has a Z-score of 1.2 would have a life expectancy of 950 hours. You've probably heard the word percentile before, typically involved in height, weight, or test scores. If you're in the 70th percentile, that means that you scored better than 70% of your peers. So a value, X, is called the PTH, pth, or the 70th, if P were 70, percentile of a data, provided that P% of the data values are less than X. So again, my example was the 70th percentile. And that would mean that you did better than 70% of your peers. In our percentile, we'll always have some sort of sample or group that we're referring to. Okay. So if we're going to look at a situation, in a recent year, the median annual salary for a physical therapist was $74,480. Median, remember, means the middle value once we put all of the values in order from least to greatest. If the 90th percentile for the annual salary is $105,900, find the percent of physical therapists whose annual salary were each of the 3 situations below. So we'll do these one at a time. And zoom in a little bit here. So we're going to look at more than the $74,480, less than the $105,900, and then the percentile that would be between those two. So I'm going to go ahead and draw a little picture to help us kind of think about it. And I'm going to use what's called the normal curve. You may have heard this called the bell curve before. And our middle value, in this case, our median, is our $74,480. Regardless of we're talking about mean or median, whatever's in the middle, we would have 50% of our data on the left of it and 50% on the right because it's the middle. And if something is in the 90th percentile, that would be our $105,900. That means that 90% is going to be less than that value. And that would mean that 10% would be above it. Okay. So we want to think about percentiles. So if I'm looking at the 74,480, how much is less than that? Well, 50%. So this would be called the 50th percentile. And then we said that the 105,900 was the 90th percentile. So that means that 90% of the physical therapists make below that amount. And then if we're looking at the value between the two, so that would be this part right here that I'm shading. So from the center point to this 105. Well, remember that each half is 50%, and this little tail is 10%. So that means my part that's shaded would represent 40%, or the 40th percentile. So 40% of the physical therapists make between these two amounts. So again, we're going to look at percentiles in respect to how many are less than your value. All right, so let's look at another problem with percentiles. And this one is going to be where we're using percentiles to find a value. Given a set of data and a data value x, the percentile score of x is going to be equal to the number of data values that are less than x over the total number of data values. And then we're going to multiply by 100 because we want it to be in percent form or percentile form. So here's our situation. On a reading examination that was given to 900 students, so 900 is the total number of students that were tested, Elaine's score was 602. So that's her score. And it was higher than 576 of the students who took the examination. So 576 of the students had a score that was less than hers or Elaine's. What is the percentile for Elaine's score? So her percentile is what we're going to find. So we're going to have a fraction, and then we're going to multiply it by 100. The first value is the number of data, or the number of people whose score was less than Elaine's score of 602. Well, that's this number, 576. We're going to divide by the total number of data values. Well, that represents the total number of students. So notice we didn't use Elaine's score in our formula. We just want to know where her score is in the continuum. So grab your calculator and take 576 divided by 900, and then take your answer times 100. And you should be finding that she's in the 64th percentile. That means she did better than 64% of her peers. We're now going to be able to use data and create some graphs. Our first graph we're going to create is called a box and whisker plot or a box plot. One of the most important things that we need to know is that step number 1 to make our box and whisker plot is to rank the data or put it in order from smallest to largest. So I have a whole table of values here, and I'm just going to go ahead and tell them to you in order so you can write them down on your paper. So step number 1, put them in order. So rather than tell them to you just in the order of the table, I'm going to tell them to you in order. So number 1 is 26, 32, 36, 36, 37, 39, 39, 40, 40, 41, 42, 42, 43, 45, 45, 48, 48, 49, 50, 53, 53, 56, 58, 62, and 73. If you didn't write those down with me as I was reading them, I would pause the video and make them down on your paper. Once you have your scores in order, step 2 says find the median of the data. This is called the second quartile. Well, to find the median, we're just going to find the middle number. So we're going to take one number off the front, one off the back, until we find the literal middle of our set of data. And as you're doing this, just keep track of where you're at, and you should find your middle number to be the number 43. So 43 represents Q2. It's called our second quartile. Step number 2, find that number. Step number 3, or C, the first quartile, is the median of the data that is less than Q2. And the third quartile, Q3, is the median of the data greater than Q2. So I'm going to use a highlighter just to show these data values are less than 43, and these data values are greater than 43. So you'll always start with that median number, and then we're going to find the middle of that set. So again, I'm going to do one off the front, one off the back. And it turns out that our middle this time is 2 numbers. Well, since they're the same, we don't have to do anything. If they were different, we would add them together and divide by 2. So this is going to be Q1 is going to be the number 39. Then I'm going to do the same thing on the second half. One off the front, one off the back. And in this case, the 2 numbers are 50 and 53. Well, I'm going to go ahead and scoot this up a little. We're going to go ahead and find the average. So 50 plus 53 divided by 2 is 51.5. This represents Q3. So we have our Q2 was our number we circled to start with, Q1, and our Q3 here. Okay. Then we're going to use those values and make a graph that looks like this one. So we're going to go ahead and make it on this page just so that you can see it. And we're going to make it down at the bottom. Again, if you're doing your own paper, go ahead and just find you a nice space. And our steps are as follows. Draw a horizontal scale that extends from the minimum to the maximum. Well, our smallest value was 26, and our largest was 73. So when I draw my line, I need to cover all of that. Well, I like to start with what I call even numbers, even though it's an odd number. I don't want to start with 26, I'm going to start with 25. And I'm going to count by 5s. So 30, 35, 40, 45, 50, 55, 60, 65, 70, and 75. And what that allows me to do is to cover all of the values and a little bit of extra space. Then we're going to start with our minimum and maximum value and put a dot above this line. So 26 would be about right here, and 73 would be about right here. Those are going to be our whiskers. And then we're going to draw straight lines at each of our quartile values. So at Q1, Q2, and Q3. Well, Q1 was 39. So there's a straight line. Q2 was 43. And Q3, 51.5. And these are a little bit of an estimate. So there's my box. And then I'm going to connect my whiskers. And that is why it's called a box and whisker plot. So something to notice about the data, since this represents the median or middle, from this whisker to this line is 50% of the data. From the whisker to this line is 25% of the data. From here to here, 25%. Same on this side. From the middle to the dot is 50%, 25%, and 25%. That represents how many of those pieces of data would fit in that category. The last thing I want to talk to you about today is a stem and leaf plot. So it's just another form of a way to display our data. So I'm going to go ahead and give you some data values, and then we're going to make one. So again, let's go ahead and write these down in order just to make our life easier. 30, 35, and then 37, 38, 42, 45, 53, 57, 62, 65, and 67. So a stem and leaf plot is going to start out with a table that looks like this. We're going to put the stem here and the leaf or leaves here. The reason I suggest having the data in order is we need it in order for our stem and leaf plot. So I'm going to go ahead and put boxes around each of the categories: the 30s, the 40s, the 50s, and the 60s. If your data was not in order to start with, that would be your first step. The leaves are going to be each of these values, and our stems are going to be our categories. So 30s, 40s, 50s, 60s. So I'm going to do a 3, a 4, a 5, and a 6. Then in order, evenly spaced, I'm going to put the second digit of each number. So 0, 5, 7, 8, 30, 35, 37, 38. Then 42 and 45, 53, 57, 62, 65, and 67. So again, a stem and leaf plot, just another way to display data. So as you're getting ready to do your homework, make sure that you keep this in mind. And if you haven't had time to jot it down, please pause the video and do that before you leave. Otherwise, have a great night, and we'll see you soon.